Hey everybody, hope you're doing well and learning a lot at home and enjoying a little bit of, let's don't call it time off, but remote education. I wanted to record a little video for you today and help you get a little bit smarter, hopefully. Specifically, I wanted to work through that Tinkercad breadboard lesson that I asked you to do at home. Many of you did a great job on that. Some of you need a little bit of help, and I thought I would go through it with you. Before I do that, I want to show you something. As you can see, unfortunately, my face is on the screen here, and I was looking, I said, well, you know, I don't look so good. That's not really new or unusual, but I wonder if I can make it a little bit better. And I thought, well, I need some more light. You know, I'm not really getting great light on me here. And so I was looking around, do I have any lamp? Do I have any flashlight, anything? And you know, of all the tools and equipment that I have in the lab, I can't find a flashlight, a lamp, nothing. And so, you know, I thought, well, I don't know what I'm going to do here. But you know, in the lab, we're resourceful. We figure it out. We find a way. We improvise, adapt, and overcome. And if you remember, the last thing that we did before we were dismissed for a COVID break, the last thing that we did was we made a circuit with a bulb. We made a light, in other words. And I got to thinking, you know what? I wonder if I can get that thing to work, if I can use that. And so I want to show you really quickly what I've done here. Let me see if I can rotate this thing around where you can see. But what I've got is, I get that thing in the picture. If you can see here, I've got the bulb that we made, and I'm holding it on to my monitor with a clamp that I printed on the 3D printer. Okay, so, and then I've got it hooked up, of course, to our you know, one of our favorite instruments, the power supply. Can I get that in focus here? Yeah, here's the power supply here. So, we've got it all hooked up and wired up here. I don't know if this meets electrical code. I wouldn't recommend this at home, but that's what I got going here. Let's see if we can get a little bit better light and get your coach looking a little bit more presentable. Of course, you know it. We can turn the voltage up and down to make it shine brighter or not. Get it in the picture really quick and show you. I think, if I remember correctly, the one I'm using, the circuit I'm using actually, I think this is the one that Avery and Peyton and Olivia made. That's Crane, Purvis, and Hodem, I think, collaborated on this particular circuit. So, putting it to use in the lab today to make your coach marginally more presentable. So, on to the task at hand. The Tinkercad breadboard lesson. All right, Tinkercad breadboard lesson. Here we go. What I've done here, I'm going to browse to tinkercad.com/dashboard. You all should know how to do that. We're just going to go to Tinkercad, and then I'm going to select Learn. And I'm going to change it over here from 3D to Circuits. And I'm going to go over to Lessons. And the one we want is Introducing the Breadboard. All right, here we are. One of 6 over here on the left. One of 6 screens we're going to do. Before I go through this with you, let me remind you about you know, the breadboard, what it is, what we do with it. Why is it called a breadboard? We went over this in class, but I want to take a minute to refresh you. So this breadboard is something we use for prototyping circuits. Remember we learned about prototyping. So basically this is not the finished product. It's not the way we're going to leave it. It's basically an experiment to see, can we get this thing to work? And then we'll improve it from there. So that's what we mean when we talk about prototyping. And a breadboard is something that we use to prototype circuits. Why is it called a breadboard? I want to show you a couple of pictures here. So literally they would prototype circuits on an old board. And I think they found that the boards from a bakery worked well. Maybe they were soft or something, I don't know. But anyway, they used breadboards. Here's an example. This is somebody's got their wires stuck all in a board here. Here's another one. They just stick them in a board on a piece of wood and put all their components on there, and that's their circuit. And that's how they used an old board to do it. Now we have these modern things that work so much better. They're all fixed up for the purpose of prototyping circuits. One second. So you remember I got this one that I was showing you in class. I'm trying to get it up here where you can see it well. And I pulled the back of it off so you could see how it's got all of this, how all the metal strips run. And so that's basically what we're showing you here in Tinkercad. It's just a virtual version of this. It's just a software version. And so we'll get together, we'll fire up Tinkercad here and work through this, and you'll see how we can use a breadboard to prototype a circuit. All right, so opening up that lesson, we get a breadboard sitting here on our desktop. And looks good, okay, everything's fine. Next, so we go to 2 of 6. Along the left and right sides of the breadboard are columns called power rails. So here's the left and right side column. These are power rails right here. This is where you hook your electricity to it to supply power. You can see they're labeled positive and negative. Remember we talked about that. Electrical circuit will have a positive end and a negative end. Hover over any of the holes in the column next to the plus, and you can see how the whole thing lights up. That's what it's showing you there, is that these are all connected. If you can see how it's all lighting up in green when I move, it's showing you that they're all connected. Okay, so let's add a battery now. Step 2 is click components and add a battery. Here it is. Let me drag it over here. I'm going to resize a little bit so that we can see a little better. I'm going to rotate our battery around. I'm clicking on this this button up here in the top left to do the rotate. I'm going to drag it down here and hook it just right there. Okay, so now we've got it. We've got the battery hooked to the power rails there. Let me do that again in case I went a little fast. I'm going to drag this battery, drop it right there where the two doodappers hook up to plus and minus. Okay, next. Now we're going to add an RGB LED and a resistor. Now, RGB LED, don't let your mind be blown here. That just means a red, green, blue light emitting diode. I guess that is still some fancy words, but anyway, here's what we want. It's this thing right here. It says LED RGB. I'm going to drag it over here onto the desktop and rotate it 90 degrees, it says. So we're going to do the same rotating thing like we did before to the battery. Okay. Place it on a breadboard with the top pin in E13. So you'll see along the top of the breadboard, the columns have labels, A, B, C, D, E, F, G, H, I, J. And down the side, the rows are numbered, 1 through 30 in this case. And so what they want us to do is drop this LED such that the top leg lands in, what did they say? E13. Okay. Bam. Done. And you can see here, here's column E, row 13. That's what we've done. Hover over each leg of the RGB LED to see the labels for each pin. So let's do that. So when I hover here, it says red. This is called cathode. I'll tell you about that in a little bit. So red, cathode, blue, green. Okay? Step 4, we're going to click Components and add a 480 ohm resistor with one leg connected to the cathode of the LED at D14 and the other connected to D18. Okay, so your mind might be blown a little bit here. All kind of things that might be new a little bit. 480 horseshoe resistor is what that looks like it says. It's not horseshoe, that's the symbol for ohm. And if you remember what we covered in class, ohm is how we measure resistance. And we are dropping a resistor on the circuit. In this case, we want to make it 480 ohms. Okay, so let's grab a resistor. The resistor is the very first thing here. It's this, I don't know what it looks like. Rolling pin, maybe? I don't know. So there's that thing. And they say they want it to be 480 ohms. So I'm going to come up here to the properties of this resistor, select it, and you'll get, if I select the resistor, I get a little box here. And right now it's showing 1 kilo ohm of resistance. K horseshoe. That means kilo ohm. And we're going to change this to be 480. But instead of kilo ohms, let's make it ohms. In this case, the single horseshoe. And I'm calling it horseshoe because that's what it looks like to me. I don't know, but it means ohm. Okay, so we've done that. One leg connected to the cathode of the LED at D14. So I'm going to drag this thing over and drop it in D14, which, as you remember, is the cathode leg of the LED. And the other, we want to connect to D18. So that is how it landed. That's right. D14 here and D18 is how I've dropped that resistor in there. All right, so that's looking good. Step 5, finally add a wire connecting the resistor to ground. All right, so to do that, we're just going to click in one of these holes on the 18 row, and we're going to go over and drop it in the negative column. We'll call that ground. To wire up our resistor to ground. Now while I'm at it, I like to go ahead and make all of my wires that go to ground or negative, I like to make them all black. And so what I'm going to do is select the wire that I just created and change it to black. I might have gone a little bit fast there. I'm going to redo that slower so you can be sure to see. So what I'm going to do here is on the 18th row, I'm going to click in one of the holes. And then I'm going to go over and click in one of the holes in the negative column here. And so that's basically creating a wire running there. And then I just come here and change the color to black. Now, okay, that's all for the third piece of the lesson. Continue to the next step. Here we go. Add the first switch across the ravine. The ravine they're talking about in the breadboard is this big old gap running through the middle here. And they want us to add a button switch there. If you remember the circuit that we made the other day, the one that I'm using now, we have a switch in it that turns it on and off. That's we call it a toggle switch, so it's always either on or off. That's the kind of light switches you're most familiar with in your house. But this is going to be a push button switch. And so that's this thing right here. I'm going to grab it and add it to the circuit. It says rotate it 90 degrees. So again, I'm up here on this button up in the top left, and I'm rotating 90 degrees. And then we're going to drag it up here and drop it across the ravine. That's the ditch running through the middle of the breadboard. Top left pin is in E1. That is correct. That's how we got it. Okay. Now in step 2 it says wire the top left pin of the push button to the positive rail. So that's A1 to the positive rail. To do that, we just click in A1, and then we come over here and click on the positive rail. Boom. Okay. Now wire the other side of the push button at D3 to D13. All right, so I'm going to come down here to D3 and run a wire down to D13. All right. Now we're going to click Start Simulation. That's this button up in the top. Step 4 says to click Start Simulation and press the button. So if we press the button, you can see our little LED turns on red. Light emitting diode. Turning red when we push the button. Now, step 5 says stop the simulation and change the wire color to match the color the RGB LED turns when the push button is pressed. So stop the simulation and change this wire to red. That makes sense. That's a pretty good convention to keep us straight. Continue to the next step. It says add 2 more switches. All right, copy and paste the push button or create another one. Place it with the top left pin at E5. Okay, so I select the push button, Control C, Control V, and I get a new push button. Drop that into E5. So I've got my new push button dropped onto the breadboard here, 1 pin into E5. Use wires to connect the top left pin to the power rail and the bottom pin to the blue pin of the RGB LED. All right, so we're going to wire over from the top pin of the new switch to the power rail. That's positive here. And you can see that's similar to what we did for the first button. And then we're going to go from the bottom to the blue, which in our case is on row 15. So we'll go here, blue, and we'll go ahead and change the color of that wire to be blue. And you know, one thing we do is test frequently, right? We do a little stuff and test. So there we are. Our first one still works, and now our second switch also works, turning the light blue. All right. Repeat with one last push button whose top left pin is at D9. All right, so we're going to select it, Control C to copy, Control V to paste, and we're going to drag it over here, and it said it wanted to put it in D9. And so, top left pin at D9. I don't think that's right. They mean for it to be an E9. So I'm going to drop mine so that the button lands in E9. And that's what we got there. And then use wires to connect the top to power, just like the others. And now the bottom to the green pin of the LED. All right, so here's green, and we're going to go from here to the bottom there, and that's good. Let's test it. Green, blue, red, which, as we know, RGB. It's a red, green, blue light emitting diode. And so now we're on to the next step. Congratulations on completing your first breadboard design and learning how to use the RGB LED. Now this part is kind of cool, I think. What if you want to combine red, blue, and green? And it's saying that you can hold down the shift key on your keyboard, click a push button, and it'll stay clicked. And then if we click another one, we get a difference. So now red and green combine to make yellow. So I can click them off. We can go something like, what if we go green and blue, gives me kind of And so the way I'm making those buttons stay on across clicks is I'm holding shift as I'm pressing the button, and that's making them stay clicked. So I think this is a pretty fun exercise. Good introduction to breadboards. Good refresher about circuits. I'll point out this is what kind of battery? 9 volt. Remember, volt is your electrical pressure. So basically, you've got 9 units of electrical pressure coming out of that battery. So, if you had a little trouble before, we walked through it together. Give it another shot. Tinkercad is a lot of fun. We're going to do some more stuff with it. Everybody stay safe, be smart, make good choices, and I look forward to seeing you soon. If you need anything, email me, write on Google Classroom, whatever way you need to get a hold of me or another coach if you need anything. Talk to you soon. Thanks, everybody. Goodbye.